right, so let's get into the imaginary number. We're going to do radicals today that look a little bit different than yesterday, right? So the difference is, if you look at my examples, are negatives inside the radical. So that's what this word means, negative radicands. That means what's inside the radical is a negative number, which we have not seen yet. If you flip to your last page that we did, none of that has happened yet. So what we're going to look at is, again, that imaginary number. So at the top of your page, where it says square root of negative 1 equals something, that something is I. So I write it kind of like a cursive-ish I. It's how most people end up writing it. But, you know, you can see it's kind of like, yeah, that cursive I. You can write it like a normal I. It's just got to be very clear that it is an I, right? It's not just like a 1, can't be a capital I. That's not the same thing. It's a lowercase, kind of cursive-looking I. Okay, it's not just a letter. Again, it is technically a number. So these two examples are great if you want to look at two possible answers and what they might look like. But I think because we used the branch method, you know, with all the little trees, I'm going to just do some examples down here to clarify what that might look like, okay? So maybe before we do anything, I will go through very quickly and do this one. I mean, this is a great example that if you look at an example like this, square root of negative 9, and pretend we did it with our trees, right? Your first step is always going to be take out that negative number, okay? So what we'll do is we'll break down my number. We know 9 is only really 3 times 3, right? And then this number, the negative on the inside, becomes an I. So we know that that's already there, right? And then now, I is not going to come in a pair, right? We see our pairs, pair of 3, and then what's left? Just an I. So you will never, ever see I inside of a square root, okay? But that's always the first thing I think of is get rid of this negative and bring it out as that I, okay? Just kind of bring it with you as you go, or put in your final answer as well. Either way is fine. But that's definitely a good thing to look out for when you see a square root, right? If a negative's on the inside, take out an I. So that's what I'm going to go ahead and do here. Now, I think what I'll start with for number 1 and what I want you guys to get used to is doing exactly that. You see a negative, what does it come out as? I. So let's just write this as I square root 90. And then now, this is exactly what we've done for the past 2 days. You're just going to break down 90 the same way you would. Okay, so I'll go ahead and do this one with you. We've got 9 by 10. Great example. 5 and 2. 3 and 3. And then we're going to find our pairs and figure out what would end up being left, right? So I see a pair of 3s. The 5 and the 2 are just left over. So remembering from last time, what comes out? Well, 1, 3 comes out. And think about, okay, there's already an I here. But what makes more sense? I3 or 3I? Well, to me, I mean, I3 is like writing X3. It doesn't really make sense. It's not standard form. So we're always going to put the I second. So my 3 comes out. I is already there. They get multiplied, but we can't actually multiply them. And then my square root just has 5 and 2, which makes 10. So this would be my final answer. So notice if there was no negative here, your answer would just be that same thing without an I. Always looks very, very similar to what we've seen before. So I'll go through and finish some of these examples, and then maybe I would suggest kind of working along with me, and then we'll see where we're at the end, okay? And then we'll do that check your understanding afterwards. So at this point, again, same thing. I see a negative inside the radical next to the 28. Boom, I'm taking that out as an I. So now I have negative 3I, and then the square root of 28. So that way, it's more set up for me to actually do my branch, my prime factorization method. Okay, and again, I don't want to put I minus 3. That I has to come last. It should be right next to the radical. So I'm going to pick 7 and 4, and then 4 becomes 2 and 2. So highlight anything that doesn't have branches under it. Okay, take a look there. And same thing, let's look. Okay, I see a pair of 2s. So a single 2 comes out. That's 2 times negative 3I, because again, that's already what's left. And then what's left inside the radical? Well, 7. 7's the only thing that I haven't touched at this point. Now, you just got to be careful. You want to leave things in standard form. So I'm going to multiply the outside. 2 times negative 3I would just be negative 6I with the square root 7 next to it. So that's your second example. Okay, the rest of these on here, I'm going to kind of just speed through, take the notes on it, and then use these notes, when you look at your next page of work and you're doing the boom carts. Definitely a good thing to look at. Okay, number 3, we take out our negative as an I. We get 4I. And I'm going to do my branches, which would become 9 and 3. And then 3 and 3 again. Looks like this is a very nice problem. I'm going to take out a 3 on the outside. So 3 times 4I already, with a 3 left on the inside. And then we got our final answer. 12I root 3. So now let's take a second and think through. There's going to be something unique about 4 and 5. Both good problems. So I think this is good that we do most of these together. So that way then you do the boom cards and then you take a look at that homework assignment. This one's a little different because, well, similarly, we take out an I. But the difference between this one and the last ones is when we break down 9, it's just 3 and 3, which is a pair in itself, right? So is there anything left in the radical? No, there really isn't, right? Because there's no numbers branched out here that don't have a pair. So that means this whole thing disappears and becomes a 3. So we already had negative 13I, and then we're just going to multiply it by 3. Okay, so they work very similarly to yesterday, like I said, but slightly different. We just want to make sure we multiply out. And they get a little confusing with the I know, but same kind of idea with those pairs. Very, very similar. So we're multiplying across. Number 5, super, super similar. Let's take out the I root 36. Think of numbers you could break down 36 into, right? I would break 36 into 6 and 6. Again, that's a pair in itself. You might get here, if you did this yourself, a little bit slower, and that's completely fine. If you picked something different, like 12 times 3, that would be fine. It would still work out. It's just you got to figure out at the end what ends up happening. Okay, so again, nothing's left in the radical in this case. 6 comes out, and then we also have an I as well. So just 6I. I6, again, not really acceptable in here. We want to make sure we have just the standard form answer. So last one. For this one, same idea, take out the I, and then for 300, I know some people kind of struggle with picking certain numbers that work here. I would, if it's a big number in the hundreds, pick, 3 and 100. That makes the most sense to me. Just try dividing numbers until it works. If you did 150 and 2, that would work as well. And then I'll just keep going from here. 25 and 4, or you could do 10 and 10, right? You could do whatever kind of numbers you got to do. And then I'm going to see a lot of different pairs come out. I see a pair of 5s, 2s. Can't go farther than that. And again, last example, we keep going from here. It looks like on the outside, I'm going to take out a 5 and a 2. So 5 by 2 by 2I is already there. And then what's left on the inside is anything that's already branched out, but doesn't have anything underneath it. Okay, so final answer. We got to keep going from here. 5 times 2 is 10. So times 2 would be 20I root 3. All very good examples to see for your next task. Okay? So we'll go over any questions tomorrow's review, and then the next day's test. I will post this video so that you can watch it if you're not here, or if you need to look at it later, watch it again on your own. Watch me explain an example, that's fine. And then right now, you will do the boom cards, log in there using the Schoology, okay? It should be linked underneath wherever this video is. And then the check your understanding. So I'll check that in class tomorrow. And have a good rest of your day, guys. I will see you tomorrow.